Hello friends, so welcome in the new video. In this video, I will going to demonstrate the real-time clock on STM32 microcontroller. So RTC or real-time clock, it's a built-in module in STM32 that keeps track of time, like hour, minute, and second. Not only this, it can also track date, month, year, right, and many. So basically, you can consider it as a timer which can keep the track of all these things, right? Now, compare this with HL delay function, where we can generate delay of 1 second, 2 seconds, 3 seconds. Now, if using HL delay, if I want to make a clock, then we have to do multiple calculations, right? But RTC can do this all calculation automatically. You have to just initialize the initial values, and then you can start this, and it will keep track of this. Okay, after 1 day, if you check, then hour, minute, second will change accordingly. Date will increase by 1, right? After you can say 5 days, date will increase by 5. All these things it can do by itself, provided it should have some required power. Required powers means what? So this is what the second sentence is. Even when your microcontroller is in sleep mode or in power off means when power is not present for the microcontroller, if the backup battery is provided, which is basic requirement, initial minimum requirement of RTC, then with the help of this battery backup, RTC can keep ticking, right? Means it can keep track of this info with this time date with the help of this backup battery. Means even microcontroller is turn on or turn off, it doesn't affect the RTC, provided that backup battery is available for the real-time clock. Now, as an initial demo, I will simply compare this RTC with HL delay, and we will going to turn on the LED with interval of 1 second, and then 1 second interval we will generate using RTC. Along with this, I will also display the time on UART. So time means hour, minute, and second, right? As like a digital clock, HH, MM, and SS. So I will also use UART to display this information. But let us compare why RTC instead of HL delay. So first thing is it can run continuously in real time, right? So without any delay, it can work in real time, right? After 60 seconds, there will be 1 minute. After 60 minutes, there will be 1 hour. After 24 hours, there will be 1 day, right? Second is accurate time base. So if you generate delay using HL, so you have to keep, many things calculated, pre-calculated, and you have to use those things. But here in RTC, it is very accurate compared to this normal delay, right? It's not just a software delay, but here different thing is there, right? Third is it can work with a low power mode. So as I told you earlier, with a small backup power, RTC can work. So let us say if you have some task that you have to perform with interval of 1 day. So in that case, your MCU or microcontroller should not stay active throughout that 1 day. You can use sleep mode, right? And with small backup power, your RTC can work. And last is it is useful for time stamping loss. Time stamping means date, month, year, hour, minute, second. So all these things you can do with the help of RTC. Now let us start with the code. So this is the our microcontroller. So let's first of all clear all the pins. Now after clearing the pins, let us provide the crystal RCC. Now for LED, we will going to use onboard LED. So onboard LED is with PB7. So configure this PB7 as a GPI output. Now we also want UART to display the time. So I will going to use UART3, which is onboard UART. Now set mode to asynchronous. Now it will enable certain pins, but we have to select our required pin, which are onboard UART. So let us select PD9 and PD8. Okay, and last is our RTC. So for that, select the timer. Now in timer, here RTC is there. Select RTC. Click over here, active clock source. Click over here, active calendar. So now we have calendar configure part, calendar configuration. So some initial values are there. So here you can see in parameter setting, we have BCD data format. Hour, minute, and seconds are given. So let us take our 22:30. Sorry, yes, 22:30. So our clock will start from 22:30. and let us select Monday, month is July, date is 28, and year is 25. Right, now we have completed all the configuration. Now let us generate the code. So it will generate the code for us based on our required settings. And now I'm going to write a code to blink interval of 1 second. Along with that, I will also display the LED toggling. It will display on UART. Okay, so let us start this. And before that, let us open the driver part, because I'm not going to write any function directly, but I will going to use this rtc.c. Okay, so first of all, we have to use two uh, variable to store the time information. For that, let us take the predefined structure for the RTC, which is RTC time type. Okay, this is the structure type, and using this, let us declare two variable, or you can say two structure. One is current time, and one is previous time. Okay, so now I'm going to use these two structure to save the information of time, and from this structure I will get the second information, and from by comparing those seconds, we will take the decision. And now I also want to display the time on UART. So let us take one array character type buffer, and size is of 64. Okay, so I'm going to load my time information in this buffer, and then I will send this to UART. Okay, so now this is the predefined information, you can say our minute and second. Now our task is finished. So now whenever I will load the program and start the or reset the microcontroller, based on this information, after initializing RTC, it will start counting internally. Now our task is to get the information of time and take the decision. And for that, we have two functions called get time and get date. So let us use those functions. RTC get time and get date. Okay, right? So in while one, we have to use this get time and get date. Okay, now here in argument, you have to pass three things. One is handle, second is variable in which you want to store the current information, and third is format of the time. So handle is our HRTC, right? And you can see this from here also. Here you can see HRTC is there, right? So for both the function. Second is our variable where we want to store this information. Again, this get time will get the information of whole structure of time. Structure means hour, minute, and second. So all this information will save in our variable. Okay, so uint get underscore t and our current time variable, right? So it will save this information as current time. And structure, we will use binary structure, right? So our time is in decimal, not in you can say BCD, right? So this is the RTC format bin. This is the structure which we want to use, right? Decimal information. One more thing, for now I'm not going to use this date, but in RTC you always have to use these two functions in sequence. So if even you want to read the time, get the time, you must use get date function. Otherwise it will not work properly, right? So make sure you have to use get date function after get time. But here, as we do not have any declared variable to save this information of date structure, I'm just passing null over here, right? Because I'm not going to use this information. But we have to use this get time after get date after get time. Now we have this information. Now let us start comparing our current time structure with if is not equal to previous time. Now here it will compare whole structure. Our task is to generate interval of 1 second. So we have to compare second from this structure. So let us use seconds. Okay, so current time dot seconds and previous time dot seconds. Okay, and if this condition will satisfy, it means both are not same. So first of all, let us load whole current time structure into previous time structure. So now next time previous time will be your current time second, and again this condition will only satisfied when second will incremented by 1. Okay, and let us toggle our LED. So our LED is with PB5, so use HAL GPIO toggle pin. Okay, and here GPIO B GPIO pin 7, sorry, not 8, so it's a PB7 pin, right? So this will continuously blink our LED, turn on and turn off. So 1 second on, 1 second off, 1 second on, 1 second off. Now with this, as I told you earlier, I'm also going to display the time information on UART. So for that, let us first of all use our buffer array to store this information, and then I will simply send that buffer on UART. So we'll use sprintf. It will store the required information into our variable, which is buffer. And now our format, which I want to print, time percentage 2d, then colon. Now 3 times I will use this percentage 2d colon percentage 2d slash r slash n. Okay, and here what I will going to print, it will be our current time dot hours. Okay, because in structure we have hours, minutes and second. So let us display first current time dot hours here, then display current time dot minutes, and last display current time dot seconds, right? And now let us send all this information on UART. So for that we have HAL UART transmit. Here 3 argument. First will be your handler H UART3. Okay, because we are using UART3. Here also you can see H UART3. Then we have our buffer. So for that, let us start this int 8_t. Here I'm doing typecasting, and buffer or variable, then length of the buffer, and last but not the least, timeout variable. So HAL max delay. This is your timeout variable. And one more thing I would like to change is this. Okay, here we should not do typecasting because this is a structure, right? So we have to simply use ampersand, right? This is current time. And now let us debug the code. So get time will get the information of time into current time. In time information we have our minute and second. So later on you can use dot second dot minute dot hour. Same way for date also. We will going to see this in future in next few videos. But right now our task is to deal with the second. That's why I'm using seconds, right? Now here this is completed with 0 error. Now let us generate the hex file, because I'm going to load this on microcontroller or on STM32 or Nucleo-144 board. Now let us release this, and then I will load this on my hardware. Now we're going to load this, and our program is RTC test Nucleo-144 board. So in run configuration, you have to select RTC Nucleo-144 board. Here also we have to select release and then run. Now code will load on our board. Now it is completed. And I'm extremely sorry for one correction. So instead of the, let us first of all, let us copy this code. And one mistake which I did, instead of this GPIO, we have to use UART, right? That's why my code was not working properly. But now as I will use this, my code will regenerate. So I have to rewrite this thing. So I'm just copying those. And now it should be UART, right? Not GPIO. And now we have the code. So here nothing will change. Instead of GPIO, I have to set UART, right? So that is the correction. And then we will use same code and it should work properly. So here you can see this part will not change. I think that buffer we have to declare again 64, and then in while one I have to copy this code. Now let us release the target and upload it. Okay, here UART is open, I think. And here you can see the board. I'm resetting the target, and now you can see start from 31, 2, 3, 4, 5, 6, 7, right? 11. So here also you can see this LED is blinking, right? So this is how you can use RTC. In next few videos, we will going to see furthermore related to the real-time clock. So this is for the today's video. If you like my work, then please like my YouTube videos, subscribe my YouTube channel, share it with your friend. Till then, bye bye. Thanks a lot.